So let's look at one more example in section 5.1c um, that will deepen our understanding of doubling times and other related notions. So here we have a colony of 1,300 bacteria, and it's growing at a rate that will cause the population to triple in 4.25 days. And the first question says find an exponential growth function for the population. So that's where we'll start, is finding the model for this. So obviously this is different because we've never seen a tripling time before. We've seen doubling times, but we haven't seen tripling times. However, we can still basically handle this the same way. Although now that I think about this, I'm not even sure that we've seen a doubling time question where we were just given the doubling time and we had to determine the model. So this could be a new question in two ways, I suppose. But in any case, let me talk about a general approach here. So when I see this problem, or a problem like this, I'm going to classify it. And so what group of problem this belongs to is a... now I know this isn't a doubling time specifically, but I'm gonna call it a doubling time given type problem versus a looking for doubling time problem. Now, I know this is not specifically asking about the doubling time yet, or giving you a doubling time yet, but it's the same notion. So you have to draw a distinction between this type of problem and this type of problem. The latter type of problem, when we're looking for the doubling time, this is when you're going to use calc-intersect. And you have to have the model. Now, the first type, when we are given the doubling time, let me make this window a bit larger. This is really going to amount to a two points given type. It's really the same thing. And so this is related to what we've just been talking about. We're given 2 points, then we can either use exponential regression or we can use that new formula. I'm going to use exponential regression to get my model. So what are these 2 points that I'm talking about? Well, here they are. At time 0, we have 1,300 bacteria, and then after 4.25 days have elapsed, we have 3 times that, which is 3,900. And so those are the 2 points we're given. And that's, as in terms of a tripling time, this tripling time is, I just multiply the output by 3. That's really the only alteration I had to make. The mistake I see people make in these types of problems all the time is that they'll want to put in 0 and 3 here, or you'll want to put in 0 and 2, but that's not what you do. It's not that you put in 2 right here. You put in the amount of time that it takes to double or to triple or whatever, and that's the value. So our L1 values are going to be 0 and 4.25. Okay, so with that being said, let's actually do it. Clear this out. So that's 4.25. And this is going to be 1,300 and 3,900. And then I'm going to do exponential regression. Sorry, I pressed the wrong button there. That's stat calc. And then exponential regression, you can press 0, L1, L2, vars, yvars, function y1. Oh, I need a parenthesis or a comma there. Let me do that again. Okay, there we go. And there's our function. 1300 times 1.29498, etc. to the x. So now we can get our daily percentage increase, which is question B. That's just the growth rate. After you've done this a few times, you can just look at this and write it down, but it's this B value minus 1 and then times 100, which is, you can just ignore the 1 and then ignore the 1 and then move your decimal place 2 units over to the right. So that would be 29.50 if we rounded it. Now, if you don't want to do it that way and you actually want to compute it, then I would need to call up my B value. So I'd go to vars, statistics, equation, B minus 1 times 100. And there's our rate. So same thing. Okay. All right, finally, the doubling time. Okay, well, now we actually are going to do a type 2 question where we're actually finding the doubling time. So don't get confused. I know I was talking about doubling time a lot up here, but none of that was about finding the doubling time, and it was actually the tripling time. So to find the doubling time, we're going to use calc intersect. So we go to y equals, that is a relic from the last problem. So we do 2 times 1300. Go to our window and check and see what our window's at. We know it triples in 4.25 days, so 3 days is, let's say if we go to 5 days, that will certainly include the doubling time. Now we could be a bit more precise about that, but this will get us the values. So let's now do zoom fit. And we can find our intersection. And that is 2.68 days. Okay. All right, so I think that about wraps up our 5.1c videos. From here, we'll go into section 5.1d and we'll talk about financial models. So that'll be in the next video.